In this topic, we will discuss some properties of water and hydrogen. In this topic, we will discuss some properties of water and hydrogen gas. The uses of water include drinking, washing, cooling, generation of steam to drive turbines, and as a solvent. In this subtopic, we will discuss some of the physical and chemical properties of water. Water is very important in chemistry. Water reacts with both metals and non-metals.
Water is a very important and abundant natural resource. Water occurs in rivers, lakes, oceans, rain, and wells. The products of a burning candle can be investigated by placing a well-lit candle on a stand and connecting it to a delivery tube. The delivery tube is dipped into a boiling tube, which is placed in ice-cold water. Another delivery tube is placed in a boiling tube containing lime water.
Attempt the following exercise.
The colorless solution formed is divided into two portions. To the first portion, anhydrous copper 2 sulfate. To the second portion, blue cobalt 2 chloride paper is immersed. Carry out the activity as instructed.
The change of color of anhydrous copper 2 sulfate and dry cobalt 2 chloride paper indicate that the colorless liquid is water. Water turns white anhydrous copper 2 sulfate blue. The colorless gas produced forms a white precipitate with calcium hydroxide. The gas is carbon 4 oxide. From the above observations, we can conclude that candle wax is made up of hydrogen and carbon only.
Some metals react with water. The experiment below investigates the reaction of sodium with cold water. Observe what happens when sodium metal is immersed in a trough containing cold water. Note the color of red and blue litmus paper. Sodium metal melts into a silvery ball, darts on the water surface, and gradually becomes smaller as the reaction continues. The solution formed turns red litmus paper blue, while the blue litmus remains blue. Therefore, the solution formed is alkaline. Sodium hydroxide and hydrogen gas are formed from this reaction.
A small piece of calcium metal is dropped into a trough containing cold water. A blue and red litmus paper in the solution are immersed in the water trough.
Calcium reacts with cold water to form calcium hydroxide and hydrogen gas. The solution is also alkaline because red litmus turns blue and the blue litmus remains blue.
Magnesium reacts with cold water very slowly to produce hydrogen and an alkaline solution of magnesium hydroxide.
The red litmus paper turns blue after a few days because the reaction between magnesium and water is very slow.
Potassium, sodium, and calcium react with cold water, forming their oxides and hydrogen gas. Some metals which do not react with cold water react with steam. Wet sand is placed in a boiling tube and a magnesium ribbon is placed in the middle of the boiling tube. The sand is then heated.
The reaction produces magnesium oxide and hydrogen gas. Magnesium oxide dissolves in water to form an alkaline solution of magnesium hydroxide.
Zinc can also be placed in the boiling tube separately.
Zinc forms a yellow solid when heated in steam, which turns white on cooling. Zinc reacts with steam much more slowly than magnesium. Zinc oxide and hydrogen gas are formed. Iron also reacts with steam. Observe the following animation and note what happens. Red-hot iron reacts with steam to produce triiron tetraoxide, which is black.
All these reactions show that metals react differently with water. Metals can therefore be arranged according to how they react with water. There is decreasing reactivity from potassium to copper.